welcome back. So let's go ahead and do this problem. We have this cereal with its sugar per serving, and we did this earlier on. We created a dot plot with it in case 8-1, I believe, clue 8-1. Where we did it again. I asked you to go ahead and get it set up, and so you can see that I did not, I needed to extend my line because I forgot about 1 and 2. When I made my line, I started it at 3 and I should have started it at 1. So I took this information and I have now everything represented that's in this table in this line plot. All right, and we're going to figure out the mean and the median. The mode is pretty easy. We can see the mode right away that it is 7 because it's the one with the most, right? But figuring out the mean, we can do what we've done before. We can add everything up and then divide. Or I'd like to show you how you can actually use Desmos to figure out your mean and median. So let me go to Desmos. And what I've done is I've taken each of the values of the cereal and I've typed them in these brackets. So do you see these brackets right here? There's a bracket and it says 1, 3, 4, 4, 4, 5, 5, 6, 7, 7. I just typed them all in. They're inside the brackets, and then on the outside of the brackets I put parentheses, and in front of the parentheses I put the word mean. And Desmos figures it out for me. It tells me what the mean is. It says it's equal to 7.631. So let's go ahead and write that our mean is 7.63. Pretty cool, huh? So really it just takes a little bit of time to type in your mean. Now you can do the exact same thing, and instead of typing mean, you can type median, and it will tell you what the median of your numbers are as well. And you can see that the median of this data is 7. So that's just a nice little trick, okay? So in this situation, our mean is 7.63, which means it's close to 8, and our median is 7, and our mode is 7. So why do you think that the mean is higher than the median? Remember when we did a symmetrical version, our means and medians and modes were all very close. And in this one, they're pretty close as well. But there's one thing that extends this, that makes this 7.63 be higher than the 7, and that's this thing right here, that 22. That's called an outlier. Notice that everything else is kind of bunched together, but then you've got this one that's sticking way out here, the 22. So what would happen if we removed the 22? What would our mean become if we remove the 22? So let's try that. Let's first change this to mean. And then let's get rid of the 22 and see what happens. So now our mean is 6.8. 6.8. So that actually made a pretty big difference if you think about it. It's a full point, right? This was 7.6 and it almost went down a full point. So without the outlier, without that 22, an outlier just means something that's kind of odd on the edge, right? Doesn't quite fit with the rest of the data. It's an unusual piece. We said it was 6. 6.83. So it's important to think about which is the better choice. So in this situation, 7 is really a better measure of the middle of our data instead of 7.63, okay? Because 7.63 kind of is closer to 8. It's still pretty close to 7. But it is important that we think about when we are trying to measure data that if we see something that's skewed, like this one is skewed, you can see it's got its tail right here, then it's better to choose the mean. It's better to choose the median for skewed data distributions. And for the mean, we want to use that when we have symmetrical data. All right? So now what I'd like you to do is I'd like you to go ahead and think about all that we've talked about. Write yourself a key idea right here. Key idea, something that you want to remember. It could be some of these things right here about skewed data or symmetric data. It might be that you need to remember what median means and how to do that you line up all the numbers. Something that you need to remember. Go ahead and write it here where it says key ideas, and I'll see you in class.